Hi friends, so today I want to show us this device I built. It's nothing more than just some people call it overcurrent protection, but I call it overload because there is no way you will get an overcurrent without overloading your system. So it's an overload protection system and also a reverse polarity protection, in the sense that if you in one way or the other, maybe you just come back drunk and you interchange your polarity for connection, the system will not come up. So it's an reverse polarity and overload protection system. So I'm going to demonstrate how this works. I'll be using this multimeter to monitor my input voltage and this multimeter to monitor my output voltage. This is my clamp meter to monitor my current. So So like I said, this multimeter is for my input voltage monitoring. Why is this is for my output voltage? As you can see the thing here. Why this is for my current monitoring. So without further ado, I will go straight to testing my system. So I have my input, my cable bringing in my input voltage. The negative is already connected. It's coming from my battery, and this is the positive. So I will go ahead and make the positive connection. So while I connect it, we take observe the LED. Remember, this is my system. I have a toggle switch, and this toggle switch is to toggle between 5 amp and 6 amps and 10 amp. There are just 5 point something roughly to 6 amp, and roughly 12 amp, 11 to 12, 11 amp. Let's say 11 and a little bit above, but anything 12 amp and above, the system will shut down. So we are going to do the practical and we are going to see how the system works. When I toggle it, it changes from each of the amperage sets. So, and this LED here is what I have set. I've used to monitor what is going on, the output, the device. So this one is a two-in-one LED. So what this one does is that the blue LED will come up if there is any reverse if the reverse if you do not connect the if you didn't connect correctly. Let's say we connect the positive to negative and the negative to positive, then the blue light will flash. Then the red light for this will display if there is an error, either there is a short circuit or anything. But note, when I connect this system at first, the red light will display. That is how I've also said I've built it. This is for if there is any wrong connection, even if the battery is rightly connected and maybe something is short circuit. Because this will be the red light is on, it will allow the system to give an output voltage. So you will now use this reset button to reset it. Probably you can say on it or reset it before the system will give an output voltage. So it is designed in such a way that once there is you connect it, the system will not give an output voltage until you reset it. This is to prevent any accidentally, or maybe there is a wrong connection, or the system is breached unknowing to you and you connect it, so you won't give any output. Why this yellow light shows that there is an input voltage coming in. So this might be on and this might not be on. So but if this is on, the yellow light is on and the green light is on, what is telling you that there is a voltage, there's an input voltage. So but there's no output voltage. Maybe there's something wrong. The red light and the yellow light might be on at the same time. That there's an input voltage or there's a problem in the system which you need to reset. But if this two-in-one LED is not on, the yellow light is on and the green light is on, it means that there is an input voltage and there's also an output voltage. So we are going to test it and see how it works. So without further ado, let's just go straight and test this system. so that we don't just preach and preach and preach and preach and preach. So let me keep it in the way that you can see. I want to properly set it so that we see everything. So I think this way is okay. So we are seeing everything now. We're seeing this multimeter. Okay, it's not clear. So we are seeing the LED now. We're seeing this multimeter. You're seeing this. So I'll be using this choke resistor to test. These are choke resistor. And mind you, I've already connected it to the negative of the battery. So what I'll be doing is this. I'll be using the positive to touch it while we see what is coming out, the current. We monitor the output and monitor our output voltage as well. So I will power it. This is my negative, as I said, is connected. So this is my positive output. So I'm going to power it and let's see how it goes. So when I power it, just observe the LED. You see, so you can see the red LED and the blue LED is up. What this is telling us that there is, what is this blinking? Okay, what this is saying is that there is an input voltage, but we need to reset the system for it to come up. So I will put this probe. Remember, all the system are having a common ground. So I've taken my ground. You can see my input voltage going in 14.3, and we don't have output voltage yet. So when I reset the system, you see the red LED is off and the green LED is up. The yellow LED is also on. So this is, I've not put the positive of this probe so that you can see the output voltage going in, going out. So you can see, so when I put the probe, you see we have our 14.3 there. Remember, this system, what comes in is what goes out. What we are doing is just a kind of protection, reverse and overload. So the first one I'm going to test, I have 10 ohms LED, 10 ohms. I connected 4 in parallel, and 4 of that, 4 in parallel give me 2.5. And if you do 12 divided by 2.5, we are going to get so I have the 4 LED in parallel. So 4 LED in parallel, and the total of that 4 LED is 10 ohms. 10, sorry, I say 4 LED, 10 ohms resistor in parallel. So I connected them in parallel, and the total of it is going to give me 2.5. So it's giving me 2.5 now. 12 volts. When you pass 12 volts through, what will be the current drop? What will be the current that this resistor is going to draw? And that's a 12 divided by 2.5. So we should have roughly 4.8 amps. And so we are going to test and see if that is what we get. Now, before I test it, I want to set this one is for the 6 amp. Why this? If I toggle this way, this is for the 6 amp. If I toggle this way, this is for the 10 amp and above. But anything above 12 amp to shut down. So I'm going with the 6 amp and test. So remember, the first one we are doing is 4.8 amps from what we calculated using this load here. So Let's see what will happen. My battery is on charge. That is why I'm having this 14 points. So it's not supposed to be, but it is on charge. So that is why I'm having this 14 points. So if I put this, now if I put this, let's observe. You can see we are having 4.9 and our voltage dropped to 12.8, 12.6. The input is 12.7. We have 4.9 and this system did not trip, it's working fine. Now the reason why this is dropped as I'm charging it is not because it's because the charger I'm using is not a strong charger. It can't deliver a good current. I just put it there, let the battery just be on charge while I develop a standard charger for it. So you see it works fine for this. Now this is another resistor. This one is not connected. I have two resistors here, 10 ohms in series, sorry, in parallel as well. And this 10 ohms in parallel gives me what, 5 ohms, right? Two of it, two of it give me 5 ohms. So if I say 10 times 2, so it gives me 5 ohms. Now when I pass 12 volts to it, 12 divided by, I'm going to have 2.4 amps. So friends, I will test. It's still on the 6 amps selected amp. So I will test this while we monitor our output current. So we have 2.5 as calculated, and this is our voltage. It's not driving more current, so it's withstanding it, and this is what we have, 2.5. Now friends, I'm going to connect these two resistors. I'm going to connect 6 of this resistor. Remember, 6 of the 10 amps in parallel. What do we have? Let's calculate friends. 10 amps, 10 ohms rather, 10 ohms times 6 inverse. So we're going to have total of 1.6 ohms when this 6 is connected. Remember, this one is not 2 ohms, so I have 6 of this. I will connect them in parallel. I will have 1.6 ohm. Now when I pass 12 volts to it, 12 divided by 1.6, I'll be having 7.5. Now this 6 amp is not designed to work for 7.5 amps. So what will happen is that it's going to trip. The red light will come up. There will be no output voltage. So we are going to do that. What I will do, first of all, I will put it here, then I will now touch this to make it bring the 6 of them in parallel. First I will test this. It's working fine, as you can see, 4.9, and this is our voltage. Now this is that of the two, this is that of the two 10 ohms in parallel. So I will join it to this phone, and let's see. Let's, before I join it, you will observe what will happen. You hear the relay trip, and let's see what will happen to the output. So when I join it, you see the system trip. There is no output voltage, but we still have our input voltage. We still have our input voltage, but there is no output voltage. You can see the red light has come up, the green light is off, the yellow light is on, meaning that we still have input voltage, but there is no output voltage. The red light is up, so which means we are going to reset. So friends, we've succeeded to test that of the 6 amps. So what about, let's test to see if it can withstand 6 amps. Now this is 1 ohms in series. This 1 ohms in series gives us 2 ohms, and if we pass 12 volts through this 1 ohm, we are going to have 6 amps. So this is designed for 6 amps, which means it's supposed to withstand it without tripping. It only trip for anything 6 and above. So we are going to test this. It's already connected. We are going to test this, keep it this way, and test it. So I will reset. Once I reset, you will see that voltage will come up. Sorry, the probe was not there. So you see that there is voltage. I've reset using this reset button. So now this is for 6 amps. This is our plan meter. So I will test for 6 amp and let's see if the system will trip. It's still on the 6 amp. So when I test, this gives me 6 and above. It trips. So friends, I will reset it with this resistor. I have a variable resistor here. I will reset it so that it can withstand the 6 amps. Now, when I put this, monitor your output voltage and let's see if it's going to trip. So, we have exactly 6 amps. We have exactly 6 amp, and this is our voltage, this is our input, this is our output, and you can see exactly 6 amp. So let's go back and test that of the 7 amp and see if our setting is still okay. So 4.8 is working fine. Let's see. So you can see above 6 amp the system trip. Above 6 amp the system trip. Let me reset and test again. I tested for 4. You can see you have 4.9. We are seeing this very well. So but when I put this two resistor on it, making it 10 ohms in parallel, you see system has tripped and we don't have any output voltage again. So but let's test for the 6 amps again and see. Let's test for the 6 amps and see. So we have 6 amps, so the system is working. Now I will now go ahead and test for that of the 10 amps. See, it's not hot, it's just warm. So I will go ahead and test for the 10 amps. So I will toggle this. So friends, like I said, I'm going to toggle this to this 12 amps. So what will happen is that I'm going to test and see. So let me explain what I have here. This is my 10 ohms 4 in parallel. This is my 10 ohms 2 in parallel, which I normally join to this 4 to make it 6 to get 1.6 ohms. This is 1 ohms resistor separate. This is 1 ohms 2 in series, and this is 1.5 ohm 2 in parallel to give me 0.75. Now what I'm going to do is that, as usual, I'll be touching this. Now I will touch. Remember, I've toggled this to the 12 amp. Let's see. Remember, in the 5 amp, in the 6 amp rather, if I touch this one, these two in parallel to the 4 to make it 6, it trips because it's above 6 amp. So we are going to test it and see if the 10 amp side can withstand it, and also test every other one. So first, friends, let's go and see. First we touch the first one, which is 4.9. It's okay, the 10 amp withstand it. We touch this, which is 2.5. The 10 amp withstand it. The system doesn't trip. Now I will touch this one to this to make it 10 ohms in parallel, giving us 1.6 and 7.5. Let's see if the system can return. Let's observe the current. Hope you are looking at the current. You have 5 amps there. Now when I put it, you see the system does not trip. It didn't trip. Look at it. You have 7.2. Our voltage, output voltage is 12. Our input voltage is 12. You have 7.2 amps. The system did not trip. Look at our output voltage is there and our input voltage is there. The two LED, small LED is glowing. Now, this 1 ohms I'm supposed to put this resistor in the water. It's getting hot. You can see the smoke is coming out. Now, this 1 ohm resistor, I'm going to test it and see. It's supposed to give me this volt. If the voltage is stable for 12 volts, it's supposed to give me 12 amps, which is the normal current, the normal load for this system to withstand, and it's supposed to withstand it. So if I put it, but if the voltage for any reason drop, it's still going to withstand. It doesn't matter. So look at our output voltage, input, and same, because our input voltage, look at if our input voltage drop, it's going to affect our output voltage. So let's see. We have 10 amps. Our voltage dropped to 11 points. So our input voltage is still 12 points. 11, just roughly 12 volts. We have 10 amps. You can see it withstands it very well. No stress. Now, the resistor has broken. My resistor is bad. So now, this is also 1 ohms. This is also 1 ohms. If I put it here, you can see. Sorry, this is not. Okay. So this is 1.52 in series. So our battery has dropped, and this is what we have now. The battery is needs to be charged with a good charger for it to be charged with a good charger. Let's just look at what we have here and see. So the trip. Did you even see what the output current is? Here I was having 14 point something amps and it trips. This is for the 10 amps. Here I was having roughly. So I'm going to bring it up a little so that so this is working at, let me see something for the 5 volts. Sorry, I need to reset. Okay, it's working well. So so I'm putting this, I'm on the 5 volt side. It's supposed to trip be fine. This is what I want. So let me take it back to the 12 amp, or so voltage has dropped. Now let's look at, I put it here for the 1 ohm. Ah, still the smell. If you have a good voltage input, it's going to work very well. So roughly 11, our voltage is burning out smoke. Our voltage is still there. So if I put it here now for 1.5, system will trip. Roughly 12 amps. System did not trip. I don't want to keep it for a long time because my resistors are shunt is burning out. So you can see, are we seeing our output voltage what is going on? 11 points. So it works at 12 volts. The output voltage drop. So at 12 volts, it's supposed to have 12 amps here. So but if I put it here, 6 amps, because remember it's on the 10 amp side, it's working fine. Now I'm putting it on the 1.5 amps, 2 sorry 1.5 ohms, two of it in parallel. I'll put it there and let's see what happens. It will trip because it's not designed for that. I'll overload it with this, it trips. So let's go back one more time for the 6 amp and see if it's still responding. Good, it's working fine. It's working for 6 amps, it's okay. I know it is going to trip. Good. So friends, we've tested the overload for these two sides, for the 10, 12, and the 6 amp, which is working very well. So we are going to test for polarity now and see. So before I test for polarity, this is my negative. I will disconnect it. I'll bring the negative to this point. I'll take the positive here. Sorry. I'll take the positive to this point. Connect it here. So we monitor and see. Then I will take the negative here. Friends, observe this LED. What will happen? So if I connect it, you see, it shows there is no input, there is no output, a wrong connection, a wrong, a reverse bias the polarity. So this blue LED is telling you that it is being reverse bias. So you need to connect it in the right way. So the reverse aspect is working, and let me connect it in the right way. My table is a little bit messy, but I needed to do this video just for doing sake, just to show you the design. See, the system works fine now. Now you press and everything is on. So we have our output voltage and we have our input voltage. So friends, this is the simple reverse polarity protection and overload protection system which I've designed. So someone may ask, can it work for short circuit? The answer is yes, to work for short circuit. But remember, a relay delay for some seconds before it trips for that short circuit. And you know what happens to MOSFETs? How long a MOSFET can withstand a short circuit? How many seconds? It will work, but so let's try it. It will work, but it may take a little bit time for the relay to trip, for some seconds to trip, and by then some things might get burnt out. So but for short circuit, fine, yes, it's going to work, but I don't advise you short circuit it constantly for a long time. So let's see, let's short circuit and see. See, it works, it trips, there's no output voltage, short circuit works fine, but I don't advise you do it constantly. This is very hot. Okay, okay, my 5 amp is working because I short circuited it at the place of the 6 amps. So let me short circuit for the let me short circuit I'm resetting it. Let me short circuit for the 12 amps and see. Short circuit fine, is working, but I don't advise you keep short circuiting this system. It's working for short circuits. Let's test one more time. So you see, it takes a little second for this to trip. That is because that is one of the characteristics of a relay. And so, thank you friends for watching. And the system is working as designed. I'm going to case this and I'm going to show you the final results after casing it. Thank you. Subscribe and like.